So we're going to factor trinomials with a leading coefficient other than 1 again. We're going to do a new method. I'm just calling it method 2, but your book or your publisher probably calls it grouping. And I've got this list of things that you have to do. You'll notice that some of them are familiar, and we've done them before. So the first, of course, is to factor out the greatest common factor, and that's always going to be the same. And then, of course, to make sure it's in good form, make sure it's in proper form. Again, something that we always do. Now, the next step says we're going to multiply the leading coefficient and the constant. Then we're going to factor the product of the above, and I know this sounds interesting, but once I start going through it with an actual problem, it'll make more sense. Then we add up the factors to see if we can find the coefficient for the middle term. And then we place each of these factors between the first and the last terms of the original trinomial, creating a new 4-term trinomial. And then we just use a method that we've already learned, which is factoring by grouping. So we look at this sample problem, and we see the first step, of course, is to look for GCF. 2 is prime, so 2 doesn't go into 7 evenly, so that means that there is no GCF. We see that it's in proper form because it's in descending order. If we want, we could put the little 1 there so we can see that it's descending order of the exponent. The next part of this said that we're supposed to multiply the first. Let's go ahead and try to make this more obvious. The coefficient of the first term and then the constant. So that means we're going to multiply 2 times 6 and we get 12. Now then it says the factors of that product, so we want the factors of 12. So the factors of 12, and I always start this way, I always do 1 and 12. I always start with the 1, and then I'm going to go to 2, see if that works. In this case it does. Then I go to 3, see if that works, and in this case again it does. And then you see that I get to 4. So I don't have to go any further, because if I started at 4, I'd be going 4 and then times 3, and then I'd go to, so on and so forth. So it's more work than I need to, but as soon as they get really close, you can check it and you can see that you're done. Then you ask yourself which of these factors adds to 7. So this is what we want them to add to. And we can see that 3 plus 4 is equal to 7. 3 times 4 is this 12. So we know that we are looking at 3 and 4. So that's this next step here. Which of these factors add to the coefficient of the middle term? There we go. So now we're going to rewrite our original trinomial, and I'm just going to write it down here real quick. This was 2m squared plus 7m plus 6. And what we're about to do is just replace that 7m. And what are we going to replace it with? Well, we're going to replace it with 2 terms that still combine to 7m. So we're going to have 2m squared, that stays the same, and our 6 also stays the same, it's a positive 6. But now we're going to do this. So we've got the 7, and we're going to change that to a 3 plus 4. So the sign rules are the same from the other times that we have factored trinomials. So we look at the second sign, and that second sign tells us that the signs are the same. And of course the first sign tells us what that sign is. So in this case the signs are the same. They're both positive. So both of these are going to be positive. What is it going to be? We're going back to this. We've got a 3m plus 4m gives us 7m. One of the most common questions is, does it matter what order it's in? And the answer is absolutely not. You just make sure that whatever you did there adds to the middle term. So hopefully you can see 7m is the same as 3m plus 4m. Now once we've got this 4-term polynomial created, we know that we've only got one way to factor that. So I'm going to rewrite that down here. And we know that when we do four-term polynomials, we're factoring by grouping, which means we are splitting it right in half, at least in this class. That's the only thing we know how to do. So we look at the first two terms and we see what we've got in common. We see that we've got an m. When we divide that m out, we're left with 2m plus 3. And remember, we always take the middle sign, so that's a plus. And then we see that in the second two terms, those are both even, so 2 is our greatest common factor. And when we divide 2 out, we're left with 2m plus 3. And of course, this makes us very happy because we see that we've got 2m plus 3. So we can, as our new greatest common factor, so we can pull that out. And when we divide that out, we're left with m plus 2. And we just factored that trinomial with a leading coefficient other than 1 using a different method. The thing that's nice about this method is it shows everything step by step, and some people really like that. The thing that is maybe not so nice is it takes longer and there is a little bit more work involved. So some people prefer the other method because they would rather do the thinking in their head, and some people prefer this method because they would rather see it in paper. You're going to have to work through them and see which method you like. So let's do a couple examples. Here we have a trinomial, of course, leading coefficient of 1. So the first thing that we do is we make sure there's no GCF. There isn't. We make sure it's in proper order. It's in descending order, our exponent, and it is. So the next thing that we do is multiply that leading coefficient times the constant, and I get 15. And now I'm going to find all the factors of 15. So the factors of 15 are 1 times 15. 2 doesn't go in, so that doesn't work. 3 goes in, times 5. 4 doesn't work, we're back to 5. So we know that we've got all the possible factors. We want, again, looking at the signs, we're going to have different signs here, right? This always tells us that we're subtracting. The second sign here tells us we're subtracting to 2. So now we're looking for which of these sets of factors of 15 subtract to 2. And obviously 5 minus 3 is 2, so this is our guy right here. So now again we rewrite and we have 5x squared, and we take the end, which is minus 3, and now we're going to replace that with 5x and 3x. So we've got 5x and 3x. Now again, with the signs, we see that they're different. That's what the second sign says. Remember, we're still using those same sign rules. And the negative on the first tells us the bigger one gets the negative sign. So a negative and a positive. And now we check this to make sure it worked. So we've got a negative 5 and a positive 3. That gives us negative 2. So we've got this written correctly. So the next thing we're going to do, of course, we see we've got a four-term poly, so we split it. And in the first set, we've got a 5x as our GCF. When we divide that out, we're left with x minus 1. This sign, of course, always stays the same. GCF in our second set is 3. Divide that out, we've got x minus 1. And now our new GCF is x minus 1. And when we divide that out, we're left with 5x plus 3. And we're good. And let's just do a couple more examples. So here, again, trinomial leading coefficient of 1 is their GCF. 6 doesn't go into 13 evenly, so there isn't. Is it in proper order? It's in descending order, so it's good. I'm not going to say this every single time because I get sick of saying it too, but this is something that you should be saying until you just look at it and that's what you know you should do. So now we see that we've got the first term and the last term, so that's going to be 6 times 6, and that's 36. And now we're looking for all the sets of factors of 36. And you can see, you're going to start to see why this is a little tedious sometimes. But we're just going to go ahead, 1 times 36, 2 goes in there 18 times, 3 goes in there 12, 4 goes in there 9, 5 doesn't work, 6 times 6, and we're at the same number, so we've got every single set of factors that we could possibly have for 36. So this is all the factors that will multiply to 36. And of course, we're not worrying about anything other than positive whole numbers here. So now, again, we keep the 6x squared. We keep the 6. And now this term says that we have to find factors that add to 13. So we find one that adds to 13. Four plus 9 is equal to 13. And of course, 4 times 9 is that 36. So that's our set of numbers there. So now we're going to transmute this 13x to the 4x plus 9x. And of course, the second sign tells us the signs are the same. The first sign tells us they're both positive. And again, we can see that that 13x is just split up because 4x plus 9x is definitely 13x. Once we've got it as a 4-term trinomial, again, we just split it. GCF in the first 2 terms is 2x. When we divide that out, we're left with 3x plus 2. Middle sign we keep. When we look at the next 2 terms, we see we've got a GCF of 3. We divide that out, we're left with 3x plus 2. Now that we've done our first factoring, or greatest common factoring, we go ahead and do the next one, and now we see, of course, that we've got the 3x plus 2 is our new greatest common factor. And when we divide those out, we're left with 2x plus 3. Let's do one more. Let's see, again, everything's in order, no GCF. So we take and we multiply the 2. 3 times 16 is 48. And now we have to start doing the sets of factors. So we've got 1 times 48, 2 times 24, 3 times 16. We should have known that one. 4 goes in there 12 times. 5 doesn't work because there's no 0 or 5 there. 6, well, that's 6 times 8. Hopefully you know that from your multiplication facts. 7 doesn't work, and we're back to 8, so we've got all our possible factors right here. Now, the next thing that we're going to do is see what we need to do. Do we need to add or subtract? This says we need to add, and we know we need to add them to 16. So we're going to look at all of our sets of factors and see which one adds to 16. And there it is. 4 plus 12 is 16. So this is what we need. So again, we go back to our original. Write the first, that's 3x squared. And the second, which is the end one, which is 16. Now this again tells us the signs are the same, but the first sign tells us what that sign is. So they're both negative. Just don't forget the sign down here. Forgot about him. So I'm going to switch that 16 out and trade it in for a 4x and a 12x. So 4x and 12x. Now when I combine these guys, negative 4x and negative 12x. That's negative 16x, so we have done well. So now all we have to do our 4-term polynomial is we split the group. Greatest common factor has an x. Divide it out, we're left with 3x minus 4. Keep that sign. Greatest common factor here is 4. I'm going to just rewrite that in there. It disappeared. Okay, so it's a 4. And remember, when we do the division, it's a negative 4. So we're dividing out by negative 4. So when I divide this first bit here, I'm left with positive 3x. And then positive divided by negative is negative, and of course 4. And of course this is good news, because these are the same. So I divide 3x minus 4 out of our new binomial, and when we divide 3x minus 4 out, we are left with x minus 4. And that's all there is. So I'll do another one with some examples, but this should hopefully get you started.